Welcome everybody to Data Engineers Lunch number 10. Looking back at 2020 and with what we did with Cassandra Lunch, I kind of beat myself up for not doing this earlier. We would be so much further along on the roadmap. And if you're not speaking, if you could mute yourself. All right, thank you. Today we'll cover one in many types of NoSQL databases. And it's just a discussion. I don't necessarily have a presentation per se, although I will bring up a few notable slide shares that I think are helpful for me in learning. And we'll just talk about key value systems and what's the pros and cons are in terms of data science, data engineering, web application development. There's so many different reasons why people use key value stores. So before we do that, I want to thank Akwi for his help and support in making this webinar / meetup / recording happen, and it goes on to YouTube, and you all can find that at a later time. Looking for folks to help co-organize and also to speak. So please reach out to Akbar. You can just drop your email in the chat. We are part of Data Community DC, which is a diverse group of people from various backgrounds, and we want to build an inclusive culture. So if you are in an underrepresented minority community, whichever way you look at it, we would love for you to come and speak about something, obviously if it relates to data engineering or anything related to data and the processing of data. Akwi, can you please mute everybody and then unmute me? All right, thank you. As you can see, Data Community DC is made up of lots of groups. There's statistical seminars where you can learn how to do statistics with R and Python. They even have like full courses that do live courses. Full Stack DC, Nova Data Science, Full Stack Data Science DC, excuse me, Data Education DC, and then the biggest of them all is Data Community DC. There's a lot of overlap, but we band it together as a nonprofit, and we provide the services we provide to the community are basically education around data and a place for professionals to basically come and present and build their own careers. So just think about that if you want to present and get recorded and share that with people. We're happy to help. What do we cover here? We cover basically the process of getting your shit together in terms of data. I feel like that's what we do in data engineering. We get everybody's shit together, we put it in a bag, and we take it to the store. And then people do stuff with it at the store, that being like a data warehouse or a data mart or a data lake. And sometimes data engineering has a little bit of overlap with data science, and sometimes it has a little bit of overlap with data analysis. So, we welcome all data practitioners here to learn more about data engineering. Normally at this time in the physical world, we would get up and take 2 minutes to talk to somebody we didn't know before. But because we're not in the physical world, what we do here is we ask new people to just, say hi, you can show your face and just introduce yourself. What brought you here? What would you like to learn or teach if you could? So I see, Alvin, did we get to you last week? I don't know if we got to you. I don't remember seeing your face. All right, he's muted. Sani? Oh, they can't unmute themselves, Akwi. You have to allow them to unmute.
Oh, participants can unmute.
Oh, okay, got it. So that's okay. All right, Lloyd.
Yeah, hi. No, I just saw the topic about the data catalogs, and it was something I'm interested in.
Gotcha. Yeah, we did that last week. We're going to probably have another follow-up one with maybe some demonstrations of data catalogs. So I think the video will be up at some point soon with a blog post accompanying it with notes. Ying, do you want to introduce yourself?
Hey guys, so I'm first time coming to this meetup. Really happy to be here. I'm currently working as a senior data engineer for a small auto refinance company called Motor Refi. Still early stages, lots of growth. Very happy that I'm in the place that I am right now, and really excited to learn more about how I can help you guys and what I can learn from you.
Great, awesome, thank you. And Kale passed on the intro, and that's all good. We'll continue forward. Group rules, if you have a question, just ask it. Be polite and courteous to others. Share what you know with us in the conversation. You can say, oh, by the way, you know, I know XYZ. You can say that. Or you can just ask a question in the chat if you feel like. Either way is fine with us. I work for a company called Anant. We do data and analytics platforms at global scale for big companies, and primarily focus on Cassandra, Spark, and Kafka, but anything else that works with that. DataStax is actually a partner and a sponsor. So is GW University around the corner from us here, and they give us great venue space. Happy to have them help out the whole community. The whole data community DC is backed by them. We have some local sponsors that have given us venue space when we've needed it. These days, Zoom is more than adequate. Organizational sponsors, these folks basically provide the majority of the funding for our nonprofit. And in return, they get exposure on pretty much every meetup. So think about that if you want to drop some dough. Any announcements? Any upcoming meetups? No. And then anybody looking for a job, anybody wanting to hire people, you can also just do a shout out. Or if you feel like, just put it in the chat. We have, you know, monthly events on Data Community DC, and let's take a quick look at what's coming up. Well, nothing. Oh, I should go to the website, Data Community DC. Usually they'll put a few things up here. Let's see. Oh yeah, Data Week DC coming up in October. Awesome. The individual meetups have their own events. We have a weekly call today, the data engineering lunch, and sometimes we do data engineering events on our website separate from this meetup. So please feel free to sign up. All right. So today, before I get into NoSQL, you know, just to remind everybody that we're following a roadmap, a general path of what it takes to be a data engineer: programming, learning how to script and automate things, databases, big part of data engineering, data processing frameworks, scheduling tools, different clouds, infrastructure stuff, and then new stuff as it comes in. We have covered a few of these topics, and today we're gonna do start the NoSQL one, and we'll keep revisiting NoSQL. And we'll talk a little bit about the history of NoSQL. We'll talk about you know, different types of specifically key value systems that are useful, that people use. Let's see. Ion asks, how can he get access to the workflow with the data engineer leaf? I have not exposed it to the outside world, but I believe there's a blog post with this up on the interweb somewhere, Ion. And I will make it public. That's a good idea. Maybe as like a README on GitHub or something. So key value, before I go into key value, just a quick kind of introduction to NoSQL. Before I go deeper, like who's familiar with NoSQL databases and what kind of NoSQL databases have you all worked with? You can just unmute yourself and kind of drop in. All right, so I'll start volunteer. Common NoSQL database is like Mongo, but we're not going to go deep into that. But Mongo can be used as a key value store. In fact, that's the common thing in NoSQL is that there is no relationship, so you basically have to know what you're looking for from the get-go. So the key value feature is kind of the foundational feature in NoSQL databases. Another common one is Redis. Redis used to be just a cache, but since people can put structured JSON in there and do some queries on there, you can even use it as a queue. It's going beyond that. Another, I don't know who still uses it, but Memcache was and probably still is used in a lot of places. Oh, we have some new. Oh yeah, Cassandra. Okay, great. We got Dynamo. Thanks, Cyan. And Elasticsearch. Yeah, I would say yes. Yeah, go ahead.
Got the whole set of graph databases.
Oh, yeah, exactly. There's Neo4j. That's one. Another one, Janus Graph. And I recently learned about one called Huge Graph. Rango, which is also NoSQL, but it also has a graph. So tons and tons and tons of NoSQL databases. So let's focus on, before we focus on what is key value, let's kind of think about the history of NoSQL. Where did it come from? And the world, as we know it, before NoSQL, essentially was relational databases. We covered relational databases the last couple of sessions. People were using databases that could fit in one computer, and as long as the computer could hold the data in memory and save it to a disk, even like a large disk, and could handle the CPUs, basically people were fine with it. And Oracle, one of the first implementers of relational database theory, became very popular. And then after that, people followed with commercial tools and open source tools. But when Google started to go on this journey of, creating their search engine, which everybody in the world basically uses, they hit a snag. And the snag was that they had more data than like MySQL could handle. And the general solution, if you have a lot of data and you still want to use relational databases, is you shard your database, and so sharding a database basically means the one machine can't deal, right? And so you shard it. Basically, you take certain data and you say, this is going to be on server 1, right? And server 2 and server 3. So if your client name started with A, you would say all the clients that start with A, all their data is going to be on server 1. And sometimes this was done intelligently so that like a multi-tenant software can basically provision databases and put it like, that's at least how Slack started. They use sharded databases to scale. I don't know what they use these days. They may still be using MySQL. And that process, is not elegant, right? If you think about it. you have to make your tooling essentially to bring up computers for you. And when data comes in, you have to make a decision. Oh, wait a second, where is this data supposed to go? And that has to be built in your application layer, right? The actual database is unaware of where it should send the data. Your application has to be aware of that. This is like before. Now there are databases that do that. They specifically do that because that is the beginning of the distributed computing world. So one machine can't deal. So people are like, well, MySQL can be clustered, and you can have many machines kind of replicating. You can have primary and secondary replicas, where the primary take the reads and the writes, and the secondary they just do the reads. Still, that doesn't solve the problem that one machine could not hold all the data. So because the limits were basically CPU, memory, and storage. And what I mean by limit is that how many people, how many users, how many requests for data can one machine really handle? So people started to distribute their technologies, right? And this is where I'll kind of pull in some outside knowledge. I'm gonna save this. Sorry about that. I'm going to save this as a resource here, which we'll give to everybody later. And when we went to NoSQL, what happened was that data was growing, more data was coming in at a particular time. So there's volume. Then there is the velocity, the speed. Lots of data was coming. There was variability, which is basically different types of data was coming in and needed to be handled. And then, one of the things that people needed, what they got in a relational world was that they need a way to verify it, right? Verify the data and also just the general veracity. So if you have distributed data, one of the problems was that you had to reconcile differences between different copies of data. So there was a list of databases that could be, there's a list of applications that could work within the world of relational, but then everything else, right, that had tons and tons of information would not be able to be handled by a relational database. So, by the way, so NoSQL could be that it does not have any relationships, but it also is kind of like, it's not only SQL. And so there's different databases that allow you to do SQL-like queries. Hbase, for example, does that. Cassandra does that. Trying to think if there's another NoSQL database that has Neo4j has a language called Cypher. It kind of looks like SQL. They all have their different names. So Hbase calls it Nickel, N1QL. Neo4j calls it Cypher. Cassandra calls it CQL. They take little subsets of it. Spark, for example, has Spark SQL. So Redis, at least when I started working with NoSQL, Redis was probably the first one, alongside Membase or Memcache. And these databases also, MongoDB, were commonly used in web applications, generally because Redis or Membase or Memcache, you could have applications that would just, you could just dump information, right? So users would come in, they would have like a session key, you could just dump it, and then just keep dumping information about that one user. So you can be like the user's username or their password or whatever. And essentially that one user's information would be found by having that one user ID. And you could add or delete data and not necessarily have to have a column field structure, right? And that's the birth of NoSQL for me. Now, other people used Hbase. Hbase is basically the open source implementation of a paper that Google put out called Bigtable, which is the granddaddy of all big data database systems. And Hbase was built on a system where the data was stored as key value under the hood, right? But it would structure it in a way where when you queried it, it looked to you like a table. Okay. What's the benefit of having NoSQL in the first place? You could have you could have 100 servers, and the database technology itself can have a very simple hashing algorithm, a partitioner, that given a particular key, it figures out which machine to send it, and it is able to get that. So Dynamo works like that. Cassandra works like that. I think RAG also works like that. And the other thing is that if it doesn't have the partitioner in the way, let's say Cassandra does, where it's on the client and on the server, it has it at the name node. I mean, there's a little bit of master or primariness in Hbase where the name nodes know exactly where the data is. So it kind of stores the metadata for where the data will be. And that's all built into the software. But it all starts with key value. It all starts with key value. So that's why we're talking about key value today. So what do we mean by key value? What we mean by key value is literally that. You know, in programming, generally, we make these structures where we have something like key, and then we have a value. And if we have two, then it'll be like key one, key two, value two. Right? And so when you have multiple keys, this is basically the similar way to look at information as if you would just have like a table, right, with columns. Right here, if you had a table and you had field 1, field 2, and field 3, right, and you had value 1, value 2, and value 3. But generally speaking, you have some sort of identifier, right? You're able to find this information in a table using the identifier, or by default, SQL databases will provide some basic indexing engine under the hood beyond the ID. You could add other indexes, and if you don't, it scans the table. But because it's in memory, it's pretty fast, so you don't really know it. If you're a DBA, you'll understand that in NoSQL, we get performance problems where people don't put indexes on their tables. And after a while, the tables get really big, and then they have a problem. But in a key value system, your whole data set is stored as this. This is the identifying attribute. You either know this or you don't know this. And if you don't know your key, then you can't really get anything here. So what you end up doing is you end up scanning the whole thing if you don't know the key. Similar to this. But what happens in a key value system is that since we're just worried about one thing and able to retrieve it, the technology that surrounds it can be fairly robust. And you can have hundreds of servers that basically just, you dump data, you get it back. You dump data, you get it back. So we'll come back to this in a second. So why do you use it and why do you not use NoSQL? Well, if you have to have referential integrity and you have to have data that is like millisecond or nanosecond important to people, we won't use NoSQL databases there because there's a consistency problem that shows up. And I disagree with this. There's plenty of NoSQL databases I've seen in the financial world. But basically, when, for example, you're going to buy something at a store and you're thinking about buying it, it's in your shopping cart, right? That the moment in which you put it in your cart, it needs to be taken off of the inventory because you could have made the decision to buy it later on. Now, if you don't buy it, it'll add it back to the inventory. So that type of concurrency issue is why people use relational databases. And relational databases are equal members of the citizenship of databases, because if you just can't build a realistic data platform without relational databases. You're kidding yourself if you don't. But when do we use it? If we want a flexible schema, right? If we don't really need ACID. So when we want to like dump somebody's information as they're using an application, just so that it can be used to render their personalized view, that's fine. It works really well for that, actually. If you have some issues with object to relational, when you make objects in programming, we keep adding and removing attributes. Well, if you keep adding and removing attributes, you have to write migrations for your databases, meaning you have to add schema, remove schema. Well, in non-relational or key value, you just keep adding more keys, essentially, right? Storing events or temporal data, you can imagine your keys could basically be the day and the time. And given a day and the time, you can retrieve all that information. So, NoSQL came out of Google, but NoSQL is used everywhere, and different variants of NoSQL are used everywhere. But the common key value systems that are used are under the hood. I mean, people still use things like Redis and Couchbase, but ultimately, because the technology has gotten better, key value, just a pure key value, isn't really used for persistent data. But your systems that you use do use key value under the hood. So what has happened with key value is, let's say in Hbase, where we started to take these key value systems and make them into a kind of a tabular system, is that they introduced the idea of basically like a column family, right? A family of keys together. And that column family under the hood is still being saved as key value, key value, key value. But you're calling it something. You're calling it something like user. And you have name, and you have email, and you have password, right? So when people look for information and they go to Hbase and say, I want some information from the user table where, I want XYZ. Well, there's probably, and you can do this, right? You can imagine that what it basically does is it combines the ID and the name to create another key. So ultimately, the user table is implemented just like this, right? ID colon name. Oh, actually, this is probably more appropriate. So basically, if I know that the table that I'm looking for, if I know the ID of that person I'm looking for, and I know the field name that I'm looking for, I'll get what I need to get. So under the hood, Hbase stores data in text files as just like this. I mean, not just like this, but similar to this. And over time, when you add data and you remove data, it manages these files for you. So key value was basically the foundation of all NoSQL databases, on this basic premise that you have to know what you're looking for. And then it started to add more and more structure to it and say, well, you have to know the table you're looking for, and in that table space, you can dump whatever you want, right? Key one equal to whatever. And then it became, in this table space, I want to be able to add a particular field. So it's you have to know your table, and you have to know your field name, and you have to know a particular identifying characteristic about that particular object you're looking for. But it's all based on the same premise: key value, key value, key value. But storing data in key values is, even though it's efficient if you need to look for that information and retrieve it back, sometimes when you're dealing with more and more structured information, it's really not giving you that much value. No pun intended. So where do people still use key value? Well, as I mentioned, Redis is still relevant. A lot of people use it for just dumping information and bringing it back. So a common use case would be, I have an application, I'm using it, And in the middle of my transactions, it just stores data on. And by the way, Redis is super fast. It's like written in C++. Whereas a lot of the big data NoSQL databases, you'll see it, they're written in Java. There's like a heap and blah 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 blah. But would I use Redis for kind of data engineering? Yeah, sure. If I have to ingest a lot of data at high speeds, what Redis can do for me is immediate consistency. I can just dump the data and retrieve it back. And in the meantime, I can take the data from Redis and I can send it to a queue to get processed into my big data database. So this is a common pattern in lots of systems where the transactional system has a fast kind of RAM, basically, and it has a disk. And if you know how Cassandra works, basically, Cassandra works like this. It keeps a key value stored in memory called memtables, and then it stores key values on disk in what's called the SS table or sorted string table. And when you look at a sorted string table in Cassandra or RocksDB, you name it, there's lots of databases that use sorted string table. They're basically key values that are sorted in one area, and that's a kind of like a partition. Where else do we see key value, raw key value? S3. You just put a file, your file name, right, is the key, and whatever payload you put in there is the value. So think about the same stuff that we would have stored for a user, in an application. S3 is pretty fast. You could serialize that object as a JSON, save it to disk on S3, and to retrieve it, you just say, hey, get this file name for me. Right? So you could do your own key value using S3. Lots of people do. Not for like simple data. They'll probably use something like Redis or some other cache for that. But let's say there's a bunch of data that needs to be stored for a user, like their resume, like the raw resume. I know people will parse it if it's like an HR system, but or the user's images. Yeah, you could store the binary data for an image in Hbase or in Redis, but you could also just store it as a file, and just the key that the file name is the reference to that information, right? And then lately, what people are doing is they're starting to use Kafka as kind of like a database. Kafka is it's an ecosystem of tools, but essentially you have a topic and you publish data to that topic. In Kafka, if you publish data as key value pairs, right, you can actually materialize tables out of that. And that's where KSQL comes from. You can use Cassandra as a key value. In fact, Cassandra, Cassandra 4 won't have it, but Cassandra 3.11 and before, you have the concept of what's called compact storage, which is the old way that Cassandra used to store data, just very, very similar to Hbase. And if you look at a migrated table from old Cassandra into like a 3.1 or 3.11 Cassandra, you look at the schema. The schema for the Cassandra table is key 1, value 1. So it still uses key value stores. And under the hood, right, even the new engine, sorted string table engine for Cassandra, it's ultimately storing stuff like this under the hood for us. So what that means is in Cassandra, if you wanted to just do a simple key value, like the ID is the primary key, and you just dump data into like a blob, yeah, you could do that. And Cassandra has like collections and lists and maps, and so you could put more structure into that field and add and remove keys in the map and still get the same effect as something like Mongo. You can also use Mongo as a key value, right? As long as you know the document ID, you're able to retrieve it. So even though we wouldn't necessarily see these as a key value stores, the concept of key value, which not in relational databases are built on, is everywhere. So technically, you can use that database as a NoSQL database. Sorry, as a key value system. All right. So, where I was going with this key value thing is that you're probably, if you're doing data engineering, like pure data engineering, and you're not really dealing with the web applications aspect of things, more than likely, you're getting the raw data. You're getting the raw data that's dumped to a data lake as key value, or you're getting the data dumped to a system like Kafka as key value. So S3 as key value, Kafka as key value. This is after the transaction has happened, right? Or in Hbase, you're getting it as an Hbase table. So when you know how the underlying structure of the system is built, you're better equipped to build something at scale, right? So for example, if I know how Hbase stores its information, I don't have to go talk to Hbase. I can just go talk to HDFS where that data is stored and read it raw, right? If I know the way Cassandra is storing information on disk as SS table, and there's actually code that you can look at how to read that data, you can read the data directly from the SS table. You don't have to actually go to the Cassandra query language to get the data. And actually, a couple of months ago, somebody released a Spark SQL a package that talks directly to Cassandra SS tables and it exposes it as a database. It literally does that, right? I don't know about Mongo, and I don't know about Redis, but at the very least, some of the NoSQL databases, you can go under the hood and get the data directly. Why would we want to do that? Well, business is 24/7, and people were okay with doing daily batches or every other hour, whereas now people want it in real time. So even if the data is coming into a system like this, you're going to have real time, and then you're going to have batch. You're going to probably have both of them. Well, your batch is always going to be slower than your real time because it has to process all the data. So that's where we end up having to go down to the key value level, because we can always be more efficient if we understand the underlying technology. Now, I shouldn't say always. You can be more efficient if you know the underlying technology. You could also do a really bad job of scanning everything, and that's not the reason why you would open up an SS table. You know exactly what you're looking for, which SS table it is in, then you'd look at it. So to wrap up kind of today's topic, and we'll just open it up for discussion, I want to go back to the concept of relational, and it's how this relational world became key values. And I'll also share this resource, so it'll be on the blog post when it gets published. So you all are familiar with, most people are familiar with relational databases, right? This is your table and courses, and it has some field names, it has some values. And these are essentially these tuples, kind of like arrays, not really arrays, they're called tuples for a reason. It's not an array, right? It's a structure of different things inside it. And what we end up, we talked about this stuff, by the way, we end up with this idea of key value at the top level, right? This is the key customer ID, and the value is the whole object. And that object could be just a string, or it could be further broken up into, like a structure, like a JSON. So most NoSQL databases are at the core key value. You're just adding more structure to your object, right? So it's assumed that you always know your customer ID. And it's assumed that you're probably not going to query it by one of the attributes. Why would you? You already know the customer ID. It's a joke. You always want to find people, that live in, let's say, California. How would you do that? Well, that's a different subject. As I said, there's lots of different NoSQL chapters we're going to be going through. And that's where, again, the idea of column families started to come. Is that we weren't just happy with having the access to the object as a whole. we wanted to be able to access the different columns. And the columns are basically key values inside a key value. But what could you do with columns inside a row, like a column family? You could create clusters of them, clustering keys. You could create indexes on them because you had a named column basically that you could do that. So that kind of concludes my overall view and presentation on key value. Let's open it up for discussion. So any thoughts on what we talked about? Anything to add? Something I missed? It was supposed to be like a high level key value talk. Ion, I know you have some thoughts about key value.
No, I don't actually. It's I was thinking about an embedded database, key value database, which is very popular these days because it's used in, I believe, in KSQL DB. Kafka uses it.
Yeah,
RocksDB. I don't know if it's like you can. It's not. Of course, you cannot build a cluster that will have to bring in your own stuff to make a cluster out of it. But it's doing a very well job with KSQL DB and probably other projects.
Yeah, so RocksDB, like Cassandra, was also made at Facebook, and actually what they have is they have a database on top of it called MyRocks, which is an implementation of MySQL on top of RocksDB. Okay, and there is there's also a database called Rocksandra, which is Cassandra using RocksDB as its table engine. So imagine the Cassandra communications protocol, streaming protocol, storage protocol, all kind of in Java. And then instead of storing it in SS tables by itself in Java, it just gives the data to RocksDB, and then RocksDB handles it. So Instagram, a big user of Cassandra, basically wanted to have a faster Cassandra. So they ended up combining the best of both worlds. Yeah, that's really good. Yeah, Rocksandra is popular. Oh, here's another one. Gigabyte DB uses Rocksandra to do basically the same thing. They have a Redis / Postgres / Cassandra compliant database that runs on top of RocksDB. Very popular. And then finally, KSQL DB. Right, when I was explaining KSQL, you put the data into Kafka with key value. Well, KSQL DB is basically taking that and storing it in RocksDB and exposing it as a relational database. So look, your input was very, very highly appreciated, Ion, as always. Any other comments? If not, we will call it a day and give you guys 15 minutes back on the calendar.
Sorry, I'm having trouble.
Apparently Siri did not want me to do that. But thanks everybody for coming. And we'll have a blog post out. And as you see on YouTube, I should bring it up. All the talks we do on here in sequence are on our blog. As well as as well as YouTube, and you can also get the slide share of what we talked about. All right. Thanks, everybody. Have a wonderful sledding afternoon. Take care, everybody.